This is MA 108, Chapter 6.1. And in this chapter, what we talk about is the law of sines. So the law of sine looks at a triangle, and this is true for any triangle, whether it's a right triangle or not. Any triangle that has three angles, and here is alpha, beta, and this is the Greek letter gamma. And so this is angle A and its corresponding opposite side A. And this is angle B, beta, and its corresponding opposite side B. And this is angle gamma and its corresponding opposite side C. So what the law of sines says is that if I take the sine of alpha and divide it by the opposite side A, so the sine of alpha divided by A, that's equal to the sine of beta divided by B. That's equal to the sine of beta divided by B, and that's equal to the sine of gamma divided by C. So the sine of gamma divided by C. And that's what the law of sine says, is that we have these proportions between the three angles of any triangle and their corresponding opposite side. So one thing I want to point out here, the sum of the two given angles must be between 0 and 180. So if you give me two angles, then they have to be between 0 and 180, not including the endpoints, right? So not including 0 degrees or 180 degrees. So in there, in between someplace. So anytime you're given a question and you have two angles in the question, if you add those two angles up, they have to be between 0 and 180, because that's how many degrees there are in all three angles of a triangle. And so if it adds up to be more than 180, then you know you don't actually have a triangle. Okay, so let's look at a practice problem number 13. Practice problem number 13 asks us to solve for the triangle. So what solve means is I find all three angles and I find all three sides. And we're given one side, side beta is 27.5, and we're given we're given one angle, angle beta, 27.5 degrees, and we're given angle gamma, 54.5 degrees, and we're given a different side, which is 9.27 millimeters. So if I look at this generic shape, we're given beta, gamma, and A. So we're given this angle, we're given this angle, and we're given the side that's in between those two angles. And so what I did first was test, and I added 54.5 degrees plus 27.5 degrees, and I got 82 degrees. So 82 degrees is between 0 and 180, so I should be in good shape. And then I've drawn a different triangle here, a different generic triangle, when I labeled beta and gamma. And then this would be alpha, and so the side opposite alpha is A, so A goes over here. So in order to find alpha, all I have to do is remember there's 180 degrees in a triangle. So if I minus away 54.5 degrees and I minus away 27.5 degrees, which remember is the same as 82, I get 98 degrees. So angle alpha is 98 degrees. And I just found that by remembering 180 degrees for all three, subtract these two, and I get left 98 degrees. So now I have to figure out side C and side B. To figure out side C, this one down here, opposite of angle gamma, and side B over here, opposite of angle beta. And so the sine of 98 degrees, this one, divided by 9.27 is equal to the sine of 54.5 degrees divided by C, and that's equal to the sine of 27.5 degrees divided by B. First things first, make sure when you're doing these calculations with your calculator that you switch to degree mode. Most of our calculators are in radian mode right now, but each of these problems have been given to us in degree mode, so make sure you switch your calculator into degree mode. And for a lot of us, if your calculator is turned off for a few days, it will switch from degree mode to radian mode by default. So make sure when you're doing these problems and you're in degree mode that you check to switch it back into degree mode each time. Okay, so how do I solve this? Well, I solve this first half first, which is right here. The sine of 98 over 9.27 is equal to the sine of 54.5 divided by c. I solved that for c and I got 7.62. Then I did the same thing. I set sine of 98.927 equal to the sine of 27.5. So I did the other half and I solved that for b and I got 4.32. So I've solved this triangle. I figured out that angle alpha is equal to 98 degrees. And I figured out that side C is 7.62 and side B is 9.32.